Thank you for coming. It's always exciting to me to see people doing Lync development and showing interest in Lync development. I started working with what at the time was Office Communication Server in 2007. And back then there were very few people developing on the platform. So I've watched with a lot of excitement over the years as more and more people have started using the platform and asking questions and coming to sessions like this. I'm Michael Greenlee. I'm the lead UC architect at Clarity Consulting, and I'm here with Ganesh Sridharan.
Yeah.
Did I say that right?
Yeah.
Who is senior development lead on the Lync team at Microsoft. And we're going to be talking about advanced UCMA concepts. I wanted to start by setting some expectations for this session. This is an advanced session. We're going to be talking about some fairly complicated development concepts within the UCMA API. These are some of the things that we're going to cover today. And these are four of what I think are the most useful tools or concepts in UCMA that are not just basic information that's covered in the documentation. And the four concepts that we're going to talk through are handling redirected calls, using the back-to-back call class, manual ABMCU audio routing, and call replacement. And then we'll have a pretty large chunk of time for questions and answers so that you can ask anything that we haven't covered that you're wondering about. Now, I mentioned this is an advanced session. The expectation is that you've done some UCMA development or that you at least are familiar with UCMA. If you haven't worked with UCMA at all before, this may be a little bit confusing, but feel free to ask questions. These are some of the things that we're not going to cover that are UCMA basics. Provisioning and deployment of UCMA applications, starting up and shutting down your application, managing endpoints, calls, IMs, conferences, and some of the coding best practices using async patterns and async development models. So we're not going to cover any of that. We're going to skip right into some of the more advanced concepts in UCMA. If you get lost or if you have questions, feel free to raise your hand or interrupt me, and we can explain a little bit in a little more detail. So the first concept that I want to get into is handling redirected calls. And before I start, I just want to get a show of hands. How many people have done UCMA development? Okay, so most of you. Good. How many of you have worked with a Lync server SDK? About half. And then one more thing before I start. Does anyone have any specific questions or topics that you're interested in hearing about in this session? Just to make sure that I, if possible, cover those.
Getting a handle to a call object and back-to-back call. When transferring a call to a conference.
Getting a handle to a call in order to get it into a conference.
There are other ways instead of using a back-to-back call.
Okay. Anyone else, specific things you're looking to get out of the session, specific topics you want to see covered? Great. Okay, we'll move on then. One other expectation I want to set is, we're going to be working with some AV calls, audio calls, and those are quite difficult to demo properly. So what we've done is we actually have two laptops set up here with the demos. And Ganesh is going to stand somewhere near the back to show the second user in the conversation. But it is a little bit difficult to follow. What we've done is erred on the side of showing real-life scenarios, possibly at the expense of the demo experience a little bit. So we'll do our best to make the demo make sense to all of you. but we're going to mostly spend our time looking through code and explaining the underlying concepts. So let's get started with handling redirected calls. So the underlying purpose of this is, one of the questions that I get a lot from people that are doing UCMA development or Lync development in general is, how can I, if I have an application that records calls or adds disclaimers to IMs or plays messages and calls or does something like that, how can I get access to other calls in the environment? How can I record all the calls in my Lync environment? How can I add a disclaimer to all the IMs? And the problem is that in a UCMA application, you only have access to calls that you've placed or that you've received. The UCMA application has its own endpoint or endpoints. And unless the application's endpoints are involved in the call already, you don't really have a way of controlling other calls in the environment. So you need some way to get access to those calls and connect them to your UCMA application. And that's where this concept or this technique comes in. The first piece of it is an SPL script. SPL is part of the Lync Server SDK, which I covered in my session with Vijay Manian yesterday. If you missed that session, it was recorded, so you can get a more detailed overview of that SDK by watching the recording. I'm not going to cover the SPL script in detail, but you'll just have to take my word for it that what that thing does is it takes any call in your Lync environment or any IM session and redirects it to your UCMA application. And the way that you do this is by, in the script, specifying the GRU, the endpoint URI of your application. When the call comes into UCMA, you need a way of handling that. And what you use in your UCMA application to handle the call is something called a default routing endpoint. Has anyone used a default routing endpoint in an existing application? Just show of hands. Okay, so this is not a concept that's familiar to too many of you. I'll go through that in a little bit of detail. But first I want to just kind of show a diagram of what I'm talking about here. So when you have a call coming into your UCMA application, ultimately what you're going to want to do is have the invite, the SIP invite from the Lync client go, instead of to the other Lync client or the other endpoint that's being targeted, go to your UCMA application. Now the problem is that by default, the message is going to get routed through the Lync front-end server to the other Lync client or the other endpoint. And your UCMA application never sees that call or that IM. When you deploy an SPL script on the front-end server, what you can tell that script to do is to take the call that comes from one of the Lync clients in your environment, and instead of sending it to the actual destination of the call, send it to your UCMA application. And at that point, you can do a number of different things with it. Your UCMA application could just answer the call and play a message saying you can't reach that other person right now, or you need to enter a billing code or something like that. Or you can actually try to get the call through to the original destination, but maintain some control over it. And the way that you do that is using the back-to-back call, which we'll discuss a little bit more in a moment. Another option is to proxy the call into a conference, again using a back-to-back call. And the way you do that is, again, through your UCMA application. You can back-to-back the call to an AVMCU over here, and then invite another endpoint, another Lync client. Now, in order for your UCMA application to answer calls that were redirected from an SPL application, you need to use something called a default routing endpoint. And the purpose of this is to handle incoming traffic that wasn't originally destined for your UCMA application. How many people here are relatively familiar with SIP messaging? Okay. So when you're connecting a call between two Lync endpoints in the environment, the to header in the invite is going to identify the destination endpoint, right? So if the call is redirected to your UCMA application, you have a bit of a problem because the UCMA application is going to look at the to header and it's going to say, well, this doesn't match my SIP URI, so I'm not going to answer it. And then the call gets declined and your solution doesn't work. So in order to get around that problem, you need to have this endpoint designated as what's called a default routing endpoint. And a default routing endpoint is sort of a catch-all for any traffic that comes in where the contents of the to header don't match a SIP URI that's owned or managed by the UCMA application. The list that I have here is sort of the sequence that a UCMA application goes through when it's deciding how to route incoming SIP invites, which endpoint to give them to. The first thing it looks at is a SIP header called MS Application AOR. AOR standing for Address of Record. So this one is really only used by some very specific applications within Lync server. It's not something that you typically would use in development. The second thing it looks at is the to header. And it looks for a GRU, or an endpoint URI, in the to header. If there's an endpoint URI in the to header, it's easy for it to match the incoming invite message to an endpoint. It just sends it to the endpoint that GRU belongs to, that endpoint URI belongs to. The next thing it looks for is, again, in the to header, it looks for an address of record, a SIP URI that belongs to a user but doesn't identify a specific endpoint. So that's what we typically refer to when we say a SIP URI. mgreenlee@claritycon.com would be an address of record. It identifies me as a Lync user, but it doesn't identify a specific endpoint. The next thing UCMA looks at is the conversation ID. So it checks the invite, it looks for a conversation ID and a SIP header, and if there's a conversation that's already being handled by your UCMA application that matches that ID, then it goes to the endpoint that conversation belongs to. At this point, most every invite that comes into your application will have been matched. But if you're redirecting traffic to your UCMA application, none of these first four options is going to match the conversation to an appropriate endpoint. There won't be an MS application AOR header. The to header is not going to match any endpoint owned by your application. And it won't be an existing conversation. So at that point, it goes to the default routing endpoint. At this point, you have another potential issue. Because when the invite comes into your application and your incoming call event handler is triggered, you need to figure out where the call was originally supposed to go to. Because it's not, if you want to forward it to the original destination, if I'm calling Ganesh and my UCMA application is picking up that call, in order to pass it along to him, I need to know that I was calling Ganesh. The way that you figure that out is you look at the to header. You need to drill down to the request data on the incoming call, and you need to look at the to header, grab that SIP URI, and then you can use that to forward the call to the original destination, the person who was originally being called. I'm going to switch over to some code now and show you how this works in practice, because it's a lot easier to see in the actual code. And then I'll take some time out for questions. So can everybody see this okay? Is the font size big enough? Okay, so what I have here is a UCMA application that does something that sounds relatively simple, but in practice is a bit complicated. It takes incoming calls that have been redirected from an SPL script. It answers them, and then it proxies them along to the original endpoint that was being dialed. And optionally, it proxies them into a conference and then plays hold music while the two people are on the call. So what I'm going to show you first is what happens if we just use a simple back-to-back call. And so one thing I want to call out here is I'm using a specific async pattern that's not actually part of UCMA. I have a set of extension methods that I put together that wraps the task async framework in .NET 4.5. So when you see a method like this, startup async, this is actually an asynchronous operation, but it looks synchronous in the code. If I were to expand this, there would actually be a begin and an end method, and I would have to have a callback hooked up to handle whatever I want to do after the operation completes. Now, the first thing that's important when you're handling redirected calls is when you're setting up your endpoint, you need to set this property, which is default routing endpoint, on your application endpoint settings. So that's the one that identifies that this endpoint can handle any traffic that comes in to the listening port that belongs to your application. So normally with UCMA, when a SIP message comes in on that listening port that you define when you set up your application, UCMA is going to look at the to header and figure out if it matches any endpoints or not. If you set this property to true on one of the endpoints in your application, suddenly UCMA will take anything that comes in on the listening port. It doesn't matter if it matches an endpoint that your application has or not. Now, once that's set to true, then any calls that come in on the listening port are going to cause this event handler to be triggered. And so what I'm doing here is when a call comes in, I look at the request data on the event args. I look at the to header. And I need to drill down into this URI property here, which is the SIP URI in the to header. So I don't want the entire to header. And that tells me where the call was originally going to. And at that point, I can proxy the call through my UCMA application to the original destination participant. Does anyone have any questions about this? Okay, so the next thing I want to talk about is back-to-back calls. Once you've received a call in your UCMA application, often what you want to do with it involves bringing in whoever was the original target of the call. So if I want to record a call, if I want to record calls in my environment, when I call Ganesh, although I want my UCMA application to be involved in that conversation, I still want to be able to talk to Ganesh. It's not going to do anyone any good if I call Ganesh and I just get a UCMA application that records me talking to myself. So the way that you accomplish that is using the back-to-back call class. And specifically using back-to-back call with conferences. These are some of the scenarios that you can hit with back-to-back call and an audio conference in Lync. Call recording, monitoring, connecting Skype calls to Lync conferences. There are a lot of others, but these are some of the most common that people need. Now, there are a few interesting things about the experience from the caller side when you're connecting a call through a back-to-back to a conference. On the caller end, it seems to the caller as though they're on a two-party call. And the reason for that is that they're actually talking to your application. And on the other end, your application is talking to a conference. So from the perspective of the caller, they're still talking to one person, which is an advantage if you're doing things like recording, because that person doesn't necessarily know that there's something in between them and the other person on the call. And the other advantage of using this approach is that your UCMA application remains in the signaling path, as we would say, of the call. So rather than the SIP messages going directly from my Lync client to Ganesh's Lync client, they're going from me to the UCMA application and from the UCMA application to Ganesh. That means that your application has a lot more control over and visibility to the call. It can disconnect the call, it can transfer it, it can keep track of how long it's been going for, it can modify audio routes in the conference, and so on and so forth. Can I have another show of hands? How many people have used back-to-back calls in applications? And how many of you are familiar with the concept of a back-to-back user agent as a SIP concept? Okay. So for those of you that aren't, a back-to-back user agent is really just a SIP user agent, SIP endpoint, that takes a call from one user and takes a SIP invite from one user and passes it along to another user. So it kind of proxies SIP messaging through itself. And then the media between the two endpoints connects directly. An example of a back-to-back user agent is the mediation server in Lync. The mediation server takes SIP signaling from a PSTN gateway or from a SIP trunk, and it passes it along on a different SIP. It passes along the contents of the message on another SIP session to an endpoint within the Lync environment. So that's probably the most basic example of a back-to-back user agent in Lync server. UCMA has the ability to create its own back-to-back user agents to do things like call recording. Now, when you're connecting a call to a conference using a back-to-back user agent, there are two methods of doing this. There's the dial-in method and the dial-out method, and there are advantages and disadvantages to both. In the dial-in method, you have someone calling in. Call comes into your UCMA application. The UCMA application, before answering that call, goes and joins a conference. It may need to schedule a conference first in order to join it, but ultimately it joins a conference. And then it creates another call leg, another SIP session, to that conference. So you have an incoming call from a Lync user to your application, and then you have another call going out from your application to an audio conference. Now, sometimes you're already connected to someone on a call. And if that's the case, then you need to turn that call into an incoming call. Does anyone have an idea of why that's necessary? Why we can't place a back-to-back call in two directions? Right. So the reason is that you need a media offer to come from somewhere. You need the IP addresses and ports for the media stream to come from somewhere so that you can pass that along to the conference, and then the conference can accept that media offer. So you need to have an incoming call from the user that you can back-to-back into the MCU. And the way you accomplish that, if you already are on a call with someone, is you have your UCMA application do what's called a self-transfer. How many of you know what a self-transfer is? Self-transfer is it sounds very strange when you first hear it, but basically what it is you tell the remote endpoint, you tell the person calling to transfer the call back to yourself. So the UCMA application is connected to the user, and you're telling the user's Lync client, I'm going to transfer you back to the UCMA application again. The effect of that is to create another incoming call, and then you can take that call and back-to-back it through to the conference. The second method is the dial-out method. And this is just the exact opposite of what I just described. In this approach, you have the audio MCU do a dial-out, but instead of dialing out to the Lync endpoint, it's going to dial out to your UCMA application. And then the UCMA application acts as a back-to-back user agent and sends the call along to the user. So it's really the exact opposite signaling flow from the dial-in method. Any questions about that? Can the UCMA application create a conference and then I'm not exactly sure what you're asking. Right, that would be the dial-in method. So if you receive a call from a Lync client and then back-to-back that call into a conference that your UCMA application has joined, that would be a dial-in back-to-back. Well, to be clear, you can't answer the call from your UCMA application because you don't want the application to perform a media negotiation with your Lync client. You want the media to be proxied along to the AVMCU, and then the AVMCU sends back its answer to the Lync client. If you answer the call before you initiate the back-to-back, you have a problem because now you have a media session between your application and the Lync client. Okay, so I'll just repeat that for the benefit of the recording. So the requirement is to get a media session connected with the application first to play messages or a tone or something, and then back-to-back into the conference. I'm going to skip over that for now, just in the interest of time, but if we have some time later, I can talk about how you might be able to do that. Or Ganesh may have some ideas as well. Is everyone clear on the difference between the dial-in and the dial-out method? Now, there are a couple reasons, there are a couple of pros and cons to each of the methods. With the dial-in method, you have a little more control over how the endpoint participates in the conference. And I'll get into more detail on that when we talk about audio routing. With the dial-out method, on the other hand, you have more control over who you can call, and you have an easier signaling flow when you're establishing the call. Because if you want to place an outbound call to a phone number, for example, you can't, you don't usually want to call someone, transfer them back into the conference, and then have them talk to the person they originally wanted to speak to, because that will probably take 3 or 4 seconds at least, and they'll hear ringtones and they'll hear all sorts of strange stuff. So in that case, the dial-out method is preferable. I'm going to switch back over to some code now and show you what this looks like in practice. So picking up where I left off, I have an incoming call, and I've figured out who it was originally going to, who I'm trying to call. So the easiest thing I can do at this point is just establish a straightforward back-to-back call with the original destination endpoint. So I'm going to take the call, proxy it through the UCMA application, and go to Ganesh's Lync client. So let me go ahead and start this up, and we'll establish a call just to show you what this looks like from the perspective of the Lync client. And as a reminder, I have an SPL script running in my environment. So although I'm calling test user 2 in the Lync client, it's not going to go directly to him. It's going to go to my UCMA application at first. So now we have an established call. And we're going to both mute so that we don't have an echo. So a couple of things that are interesting here. One is that you can see that if I look at my Lync client, it looks as though I'm in a call with MG Test, which is my UCMA application. It doesn't look like it's a call with test user 2. And again, the reason for that is that there are actually 2 SIP sessions going on here. There's a session going on between me and the UCMA application, and there's another one going on between the application and Ganesh. So from the perspective of my Lync client, I'm actually talking to the UCMA application, but the media for my Lync client is going straight to Ganesh. Question? Yeah? The test user 2, maybe you can hold up your laptop. Test user 2 is also logged into a Lync client in the same environment. Mm-hmm. Right. Yeah, so that's that concept of redirecting calls that I talked about a little bit earlier. And I covered that in detail in my session yesterday, so I'm not going to take too much time to explain it now. But there's basically a script running on the front-end server that's taking that call, and it's telling Lync server, don't send that to test user 2. Send it to a different location. And that location happens to be my UCMA application. Right. If you wanted to get this exact scenario, you would have to run a script like that on the front-end server. However, you can still use the back-to-back call without redirecting the calls in the first place. So I could have a situation where I'm just calling my application from the Lync client. I'm calling mgtest, and it's getting proxied through to Ganesh. Does that answer your question? And we can talk afterwards if you have more questions about the script. Yes? The question is, when you call the mgtest app, bypassing the script, won't that create a feedback loop because it will back-to-back the call repeatedly? Yes. That's why I didn't call it to demonstrate. I made it do that earlier by accident. It just gets incoming calls over and over and over again. Probably bad, but it's a lab environment, so don't do this in production. Any other questions? Okay, so going back to the code, I figured out who I'm calling. And if I skip into this method here, which is to establish the back-to-back call, the code to do this is really relatively simple. And that's kind of a theme in UCMA. Usually, although the concepts are a little bit challenging and understanding the SIP messaging that's going on under the covers is somewhat difficult, the actual code you need to do it is usually not very much. And that's the case here. You can see that I have the incoming call and the original SIP URI as parameters. And what I'm doing is I'm creating a second call, second conversation, and a second call. And in the back-to-back call settings objects, I pass in the incoming call, the outgoing call, and then the original destination SIP URI. That tells UCMA where to send the outgoing call leg of the back-to-back. And then once I've created those two settings objects and instantiated a back-to-back call, I just call establish to start it up. And that answers the incoming call and places the outgoing call. And at that point, I'm connected to Ganesh through the UCMA application. Now, that's the simple way to do this. But it doesn't allow you to do things like record the call, because although I have visibility to the signaling, I have visibility to the SIP messages, I don't have any access to the media. It's going directly from my Lync client to Ganesh's Lync client. So how do I get access to the media? In order to do that, I need to actually join my Lync client to a conference and also join Ganesh to a conference, and then record the media from the conference from my UCMA application. So to show you how to do that, I'm going to shut down this application. As you can see, I haven't really implemented any error handling whatsoever. So please don't use this as an example of how to write production apps. And I'm going to switch from my establish B2B method to establish B2B to conference. This is going to do something slightly different. Instead of back-to-backing the call straight to Ganesh, it's going to back-to-back it to a conference, to an audio-video MCU. So we'll start this up. So you can see the call has been answered, but it hasn't been answered by Ganesh. It actually was answered by the Lync conference, by the audio video MCU. So at this point, I'm actually just in a conversation with the AVMCU. And I'm playing music in there just so you can tell that I'm connected. What I'm going to do now is establish the other leg from the conference to Ganesh. And to do that, I'm going to use the dial-out method that I described before. So we'll run that. So now Ganesh is in the conference, as you can tell by the lovely echo. And we have some code in here to do some AVMCU routing, which I'm going to skip over for now. And I'm just going to show you how we did that part so far. So I'll go first to my established B2B to conference method. It looks relatively similar to the other one that I was using to do a straight back-to-back to Ganesh, but with a few differences. So first of all, before I establish the back-to-back call, I'm joining my outgoing call to a conference. So I'm using the conference session join method. That's creating an ad hoc conference. Does everyone know what an ad hoc conference is? Okay. So it's joining an ad hoc conference, and it's actually storing the conference URI, which I'm going to use later, right here. And then my outgoing call doesn't require a destination URI because the destination is going to be the conference, the AVMCU. Then I establish the back-to-back call. At that point, I'm connected to the conference through the UCMA application. My next step is to create a call between the application and the conference. The reason I do that is to play the music. So the music you heard when the call was established before, that was coming from another call from my application to the conference. Once I've established that, my next step is to dial out to Ganesh through the application. But in order to do that, I need to do something that's a little bit odd, because I'm not dialing directly out to Ganesh. I could, from my AVMCU, I could just put my original destination SIP URI here. And I'll actually run this to show you what it looks like. It'll look a little bit different. If I were to do that, the AVMCU would dial out directly to Ganesh, and Ganesh would see that he was in a conference. Instead of that, what's happening is I'm dialing out to my UCMA application's endpoint URI. So the AVMCU dials out to the application. The application then creates a back-to-back call to Ganesh. So it's proxied through my UCMA application. I'll run this so you can see what happens if I change that to just go directly to Ganesh. While I'm doing this, does anyone have a sense of what are the advantages of doing that back-to-back dial-out versus a straight dial-out? Any ideas?
Can you think that the recipient of the call won't see that you're in?
Yeah, that's one of them. So the recipient of the call can't see that they're in a conference. Ganesh won't be able to tell that he's in a conference. Another one is that you retain control over that call. So if you want to remove the participant or transfer that participant to another location, you can do that. So I've done another dial out, but this time I've dialed out directly to Ganesh.
Yeah,
And
as you can see, I'm not sure if you can see, but the call actually shows that it's in a conference.
So that's a back-to-back call to a conference. Any questions about how this works, where you would use it? Okay, so we'll talk now about manual AVMCU routing. How many of you have used manual audio routing before? So this will be new to all of you. This was introduced in UCMA 3.0. And what it allows you to do is to change who can hear what other participants in a conference. There are a number of different cases where it's useful. You can allow for silent participants in a conference, someone who can hear everybody else but can't be heard. You can allow for sidebar conversations. So if you have a meeting going on with 10 people, I could have a separate conversation within the same meeting with Ganesh without anyone else hearing us. And then finally, you can enable sort of augmented reality style attendant experiences where people in the conference can hear announcements or hear an auto attendant or text-to-speech voice without the other participants hearing them. So this is kind of a visual of what this looks like. You have, let's say, 3 participants in a conference, in an audio conference. And you send a request to modify the audio routing in the MCU. What the MCU does is it now removes some of the routes between participants. So the audio from this guy will go to this one, but it won't go in the other direction. And this one won't be able to hear this one. And this one won't hear this one. There are a couple of requirements for being able to do this with an endpoint. The participant in the conference that's making the changes to the audio routing has to be a trusted conference participant. So you need to join the conference in a special mode, which allows you to perform privileged operations. And also, the audio routes that you set have to be to or from the local endpoint, the endpoint that your UCMA application is managing at the moment. So you can't have your UCMA application say, I want to change the routing between those 2 other participants. You can only change the routing from your UCMA application to another participant or from another participant. There are two methods that you can use to modify the routing in a conference. The first one just removes someone completely from the audio routing mix in the MCU. And that's removed from default routing. There's a corresponding set of methods, which are the add to default routing methods that put them back in. So if you call this method and pass in a participant endpoint, that person will just stop being able to hear anything in the conference until you add them back in. By itself is not very useful because normally you don't want to remove someone completely. You want them to hear just some of the participants in the conference. And that's where this other class comes in, which is audio-video MCU routing. This one allows you to set audio routes at a more granular level. So you can say, I'm going to allow my UCMA application to receive audio from participant A, but not from participant B. And I'll send audio to participant B, but not participant A. These two things always go together, so you have to remove participants from the default audio mix before you create the manual routes. If you don't do that, things will, first of all, it won't work. The person that you're changing routing for will continue to hear everybody. And second of all, you can get some strange behavior in the conference. So you always need to remove someone from the default and then add specific routes for them. Another thing to avoid is creating duplicate routes. You don't generally want to create two routes from your UCMA application to someone. So in order to prevent that, you need to keep track of what routes you have in place so that you can remove them later and so that you don't add duplicates. Now, I mentioned before that you don't really have control over two other participants in the conference. You can't say these two people can hear each other, but they can't hear anyone else. What you can do, though, is if you use a back-to-back call, that gives you control over the signaling for other participants in the conference. So using the back-to-back call, you can create manual audio routes for other participants by using the audio-video MCU routing instance on the call leg between your application and the conference. I'll show you what that looks like in the code. So once I've done my dial out to the destination participant, which was Ganesh, I have a method here that says modify audio routing. And this is the one that I'm using to change the routing of the audio between the participants. The first step is to call the remove from default routing method. And I'm passing in an endpoint that corresponds to my test user 1. So that removes me from the default routing mix, so I can't hear anyone else in the conference at that point. Once I've done that, then I create this outgoing audio route object, and that represents a route between the UCMA application and my test user in the Lync client. And I pass that in a list of outgoing audio routes to this method, update audio routes. Once I've done that, there's an audio route between me and the UCMA application, but not in the other direction. Does anyone have questions about this code or how to use manual audio routing? The last thing that I want to talk about is a concept called call replacement. And this is sort of a trick. It's not actually built into UCMA, but it's a SIP concept that you can use if you write a little bit of extra code. And the concept of call replacement is that it allows you to sort of take over a call between two other participants. There are a couple of applications for this. One of them is HA, high availability. If you have multiple instances of your application and one of those instances goes down, you can recover the call from a different instance using call replacement. The other use case for this is switching participants in a call or in a conference. When you're doing a dial-out, for example, from an audio conference like we demonstrated earlier, you can actually move people between conferences in a sense. So you can have a different conference dial out to that person, and replace the connection with the initial call. So you can effectively take someone who's in conference A and put them in conference B, and then put them in conference C, and so on and so forth. There is one implementation of call replacement that's in UCMA, and that's in what's called the supervised transfer. Supervised transfer is when you call the begin transfer method, but instead of passing in a SIP URI to transfer to, you pass in a different audio-video call object. And what that does is it transfers the initial call, and when the call comes in, it actually takes over the other call. So the person who is talking, who is connected with your UCMA application, is now connected to a different call with your UCMA application. This is sort of a visual of what happens in a call replacement. So you have a call between two Lync clients as an example. Your UCMA application calls one of the Lync clients and commandeers the call that was originally between the two Lync clients. So the person on the right doesn't know anything happened. From their perspective, they're still on the same call. However, the media is now coming from your UCMA application rather than from the other Lync client. In order to do this, you need to know a few pieces of information. You need the call ID of the call that you're replacing. And you also need the from and to tags. These are parameters that are on the to and from headers in the SIP messages that go back and forth in the initial SIP handshake. And then you also need a call that will replace the original call. As I mentioned, there isn't a native method in UCMA that does this. So if you want to use call replacement, you need to write a little bit of extra code. And I'll just switch over to my demo machine again to show you what that looks like. So what I've written here is an extension method on the audio-video call class that handles call replacement. What it's doing is it's grabbing a couple of pieces of information from the existing call, the one that's being taken over. And those three pieces of information are the call ID, the from tag, and the to tag. Excuse me. In this particular case, because this is an outbound call, we know that the local tag for the local participant, is the from tag, and the remote tag is the to tag. Then we establish a new outbound audio-video call, but we add an extra SIP header to it, which is this replaces header. And the replaces header is actually a SIP concept beyond just Lync server. It's not specific to Lync server. And what it indicates is that the call identified by this information, call ID, from tag, to tag, is being replaced by the new call. So when I call begin establish with these extra options added on, with the extra SIP header, what happens on the Lync server side is that call that was already there gets taken over by the new call. The person on the other end doesn't see any change in their Lync client. It looks like they're still connected to the original person. But now suddenly they're connected to your UCMA application on this particular call. Are there any questions about call replacement? Okay. Those are all the concepts that I wanted to cover. We have about 15 minutes remaining, so I'm going to have Ganesh come back up, and we'll just take questions on any other UCMA issues, concepts, troubleshooting.
Regarding capacity and limits of this, what you've shown,
Mm-hmm.
you back-to-back every call in the system. Is there a penalty if you don't do much with it? And the second, regarding conference, is there a limit to how many conferences I can create?
So the question is, with regard to scalability and capacity, are there implications in creating all these back-to-back calls? And secondly, in creating all the conferences, is there a limit to the number of conferences you can create? There are a couple of scalability considerations when you do this. The first is that all of your calls are getting, all the signaling for all of your calls is getting proxied through your UCMA application. So you have a lot of traffic coming into your application and then going back out again. However, the media is still going point to point. And the media is creating a much heavier load on network and on the servers than the signaling is. So generally, you hit limits with the media a lot faster than you hit limits with the signaling. So usually, the UCMA applications can handle a lot of that SIP traffic. The bigger issue is the conferences. If you start creating a lot of conferences, the first thing that's going to happen is there's a limit to the number of conferences you can schedule in a Lync environment. You can expand that in PowerShell, but I think there is a maximum. I forget what that is off the top of my head. It's in the thousands. But if you're doing call after call after call after call, you will eventually hit that. The best thing to do to avoid problems is when you create those conferences that you're using to handle the media, it's important to make sure that they have a short expiry time. Or you can recycle conferences, which some people do in high-load applications. Just have a pool of conferences, put your endpoints in there, let that call complete, take them out again, put it back in the pool, and then use it again for the next call. Other questions? Questions about anything else that we didn't cover today? Yeah.
How can you add modalities to a conference?
Question is, how can you add new modalities to a conference? There are two ways. When you schedule a conference, you can specify the modalities that are included, or the MCUs that are included. I think by default, with an ad hoc conference, all the modalities are included.
Yep.
But you can remove them if you schedule the conference. You can say, I only want audio.
I want my app to participate as an IM. Do I have to download from my app?
If you wanted to add, so the question is, if you wanted to have your application participate in IM on the same conference, how would you do that? The easiest way is just to take the handle to that same conversation object and create an instant messaging call on that conversation. And UCMA will figure out that it's already joined to a conference, so it's going to place a call to the IM MCU, and you'll get instant messaging with the conference participants.
You would do that after joining the conference?
Yeah.
Right, you would do that after joining the conference.
Question about the voice XML browser. Can you take that answer? Or we're using UCMA, and for playing prompts, we use the voice XML browser object.
Hmm?
And when we want to stop playing voice XML execution, we use the stop pacing function, but it takes some time before it shuts down the audio flow or the audio. Do you have any plans to immediately cut the audio?
So the question is, today, when you call the stop async method on the voice XML browser, there's a delay in cutting off audio. Are there plans to change that? That's a question for Ganesh.
Yeah. We have a lot of applications using VXML browser that ships with UCMA. I haven't specifically encountered such an issue before. I'm not. The stop async also kind of depends on how you've written your VXML script itself. So I'm not sure where the problem is. What I would suggest is you should just engage with the support team and see if we can help out from looking at your VXML script or taking a look at your specific instance and get back to you.
So the question is, Skype users today can IM with Lync users. Is there a way to get audio from Skype into a conference? Is that right? There is. There's a bit of a caveat in that you can't join a Skype user directly to a Lync conference, so you need to use a back-to-back call. Right. So if you look at the code we have here in the established B2B call method, all of this would be the same except the destination SIP URI would be a Skype user. Or option 2 would be you receive a call from the Skype user in this application, then you do a back-to-back using this method to the conference. So your incoming call is from Skype to the application, and then you call out on the other call leg to the conference.
Okay.
The code for this sample. The question is, can the code be available afterwards? I'll post the sample code on my blog. I'm not sure if we can make it available through the conference website, but if it's possible, we'll figure it out. Yeah?
Can we take a quick look at your async extensions?
Sure.
What the pattern is there?
So the question was, can we take a look at the async extensions? I'll open up one of the simpler ones, which is the call one. These are actually available on Codeplex, by the way. The URL, I think, is ucmaasync.codeplex.com. So if you want to check them out or download them, that's where you can get them. This is the pattern that I used. So it's kind of boring work. I just created a method for every single UCMA begin and end method pair. And it just turns the whole thing into a task which you can await on. Just zoom this in. Other questions? Ganesh, anything else you want to add or cover?
Nothing that I can think of.
Okay, well, thank you all for coming today. If you have more questions about specific things, you can feel free to come up to us afterwards. We'll be around for another 5 or 10 minutes.